Uh, Thank you, everyone. Thank you for the May LA Meetup group. And today we are going to talk about Mule reliability with transactions by Ryan Hogg. I'll kind of take few minutes regarding the introduction, who manages the LA Meetup group, and after that I'll just hand it over to Ryan, and in the end we can have few minutes for the questions. I think we are doing really good networking, but we'll take some more time if necessary. So about the speakers and organizers, my name is Rohit Malik, and I'm here in Santa Barbara, California, and I'm an engineering manager at a Folio Incorporation, and I'm a MuleSoft leader and mentor, and I manage this LA Meetup group. Along with me, BPS is not here. He is my co-organizer of or administrator of this group, and he also here in local in LA basically. Ryan is going to be our speaker today. He is president of Hogue Software Company, and thank you, Ryan. And you can take your introduction later on when you start your presentation. Safe harbor statement. Neither of the speaker or the host are organizing this meetup. We are just organizing this in our individual capacity, and we are not representing any of our companies here. This presentation is strictly for the learning purpose only, and either the organizer or the presenter do not hold any responsibility that same solution will work for your business or your requirements. There will be no promotional activities here, strictly no for that. In the end, for the just housekeeping items, we are recording this session, and we will be uploading this particular recording onto our regular channels. And you can submit your question through the chat. It is pretty open today. And if you want to unmute yourself, you can unmute and ask any of the question. It is pretty good. I'm happy. Last time we were not able to do that. It is going to be, I hope it is going to be very interactive. And let's keep it as very interactive, discussion based, informal. And we all are here for learning purpose. Let's get the best out of it. Share your feedback after the meetup, and we'll be happy to improve. We may not be doing this in a perfect way, but happy to improve based on your feedback. You can suggest any of the topics if you are interested in presenting, or you want to have any presentation of the future meetups. You can provide your topics, and we will try to find out the presenter, or we will try to present ourselves. And in the end, I request that we stay on this before the presentation. We stay, and we'll take a group photo and try to market this group a little bit more. And with that, I'll hand it over to Ryan. Ryan, over to you.
Okay, let me get the screen share up. You guys ready to get technical? I like technical stuff. So a couple things. First of all, I am with Hague Software, and I'm also with Integration Quest. So we have that's sort of a new brand for training and stuff. So we do. I wanted both of those out there. And my last name, Ryan Hague, is how you pronounce it. And we are going to talk about Mule reliability with transactions. I just found out that we have a shorter time here, so we're gonna summarize some of the things I had planned to talk about. I could probably do this talk for 2 hours, and you don't have that long, so we are going to keep it shorter. So reliability and transactions are both kind of charged words. So we want to make, in general, I think it's an important topic because reliable integrate. You've got a lot of you got a lot of other applications that need to work together, and Mule's in the middle. And the last thing you want is for Mule to be falling apart and the application and the integration not to work. And a lot of times the first thing that comes when an integration doesn't work, when anything is not working, the first thing people, oh, Mule's not working, Mule broke. Like Mule's, it's the first thing to take the blame when the systems aren't working together. So what I want to do is make sure that out of everything, Mule is the last thing that has a chance to break. It's the rock solid stuff in the middle, right? So that's what I mean by Mule reliability with transactions. Now, I am going to be very happy to have this meeting informal, the way Rohit said. We're going to be happy to take questions. I don't really just want you to unmute. It would work better. I mean, I do a lot of classes, so I'm in virtual meetings a lot. It'll work way better if you use the the reactions panel. There's a hand raise button, and I have got all of your names up in my other window. So if somebody raises their hand, I can see that, and I will stop, and that's the best way to do it. So somebody test me in the first couple of slides and raise your hand, and I'll show you. So that's how we do the participation. I think that'll work best. So let's talk about what I mean by transactions. It's one tool in the toolbox. It's not all you need to make a Mule application reliable. There's a lot of them, and I'm not going to list them because we're going to focus on transactions in particular. Now, transactions are not just a Mule thing, right? Transactions are they're a tool that many different software platforms use, right? So that we're going to start with the term transaction. It's an English word, right? It has a prefix trans and a root word action. So a transaction is an action that takes place across boundaries. It's a composite action, right? So here's an example of a composite action you might want to take. You might want to accept a job offer, and in order to take a new job, one of the things you got to do is sign the offer letter, right? But you don't want to sign the offer letter and not resign from your job. So you got to do all of these actions together. And if any one of these actions fails, you certainly don't want the other actions to succeed, or else you might be left without a job, right? You're going to need to take the new job and resign from the old job and tell your family and friends, and it would be awkward if any of these things didn't happen as a unit. So we're going to be talking about taking many actions as one unit, this whole presentation. So it really is about how do I make an integration do a group of actions, all or nothing, right? A unit of action. And we call that, there's some formal language for those. So, and we're going to talk about that particular part as the atomic nature of a transaction. So you're going to define non-functional requirements for an integration that include atomic transactions. So an atom is a unit, right? So an atomic transaction is some way that you define a unit of work, a unit of action that you want the application to take. And then that's not all we care about. We don't only care about a unit of work. We care about the rest of these different non-functional requirements. And there's a nice acronym for it, ACID, that you can Google. So it's, when you're looking at building a reliable unit of work in your Mule application and you're trying to make sure you get the right requirements, this is an architecture concern. This is a nice way to remember, oh, did I consider consistency? Did I consider isolation? So I'm going to take you on a little tour through those non-functional requirements before we look at coding it, right? So an ACID transaction needs to be atomic first. So how do we define the atomic unit of work? That's called demarcation. Demarcation is like, how do I draw the line around it? How do I say what the actions are that belong in and belong out of my transaction? So that's how we call demarcating a transaction, and there is a way to do that in Mule. The end part, like when you finish the transaction, you have an action called commit or rollback. So that's how you know when it ends. So an example of demarcating a transaction might be in life, might be a kindergarten field trip. So imagine you're managing, you're responsible, you're one of the teachers or something on a kindergarten field trip that has 23 students. So you have to say what's included in the transaction, right? So we're going to include all 23 students, all 4 parents that are there, and the 2 teachers, right? We're a group. So you've demarcated a group of data, in this case, a group of people. And let's say you're on the way home from the field trip. When you exit the museum, you need to board the bus and depart for home. And you need to make sure all of you guys board the bus before you depart for home, right? Otherwise, you better not depart for home, or you're going to leave some kids behind. So that's demarcating, determining exactly what belongs in scope for the transaction, and what actions matter. So in this case, it would be boarding the bus and departing for home. That's demarcation. Okay, so once you've demarcated your transaction, you want to, one of the other non-functional requirements that are defined for your transaction is consistency. So when my transaction completes, I want the systems to be valid. I don't want to corrupt my data. right? So I need to finish the transaction in a way that leaves the systems in a consistent state. So in order to know what consistency is, then you have to define validation rules. So that's how you know what is consistent or inconsistent. So an example on here is for some consistency rules if we were at an in-person meetup, right? So Rohit would invite me to come. I would ask for Rohit and Aditya to help me during the talk and let me borrow their car keys, right? And then later on in the talk, I give Aditya his car keys back, and then we complete the meetup and I leave. So we might have an inconsistent state of the system, right, Rohit? That's very inconsistent. So that would not be allowed. We don't want to allow that inconsistent state at the end of the transaction. You need to take all the actions needed for the system to be consistent again, like giving Rohit his keys back, right? That's consistent state. So any transaction, you see how it requires you to think about what the validation rules are for the systems that you're touching, right? Maybe it's a database, maybe it's Salesforce, maybe it's whatever you're interacting with, right? You can mess up the data, so your transaction shouldn't, and you need to define what that means for each action. So that's the consistency requirements of your ACID transaction. You also, in addition to those requirements, are going to want to consider isolation. So how do I keep all the different transactions from interfering with each other? And I think a good example of those kinds of requirements might be like in your source control system. So we have all of us writing code together, and I clone the repo and you clone the repo, and Whitney clones the repo, and we all are making our changes. And in the chat, put who wants to be do you want to be the first one to push your changes or the last one? What do you think? Put first or last in the chat. Who wants to be first? Who wants to be last to commit and push? Vikas wants to be first. There's a good reason, right? Why do you want to be first instead of last? Because whoever's last has to do what? Oh, Rohit's happy to be last. He's going to stay late on a Friday night.
Yeah, I can I can resolve the conflicts in the end.
Yeah, because the last one has to deal with merge conflicts. So you have a transaction and I have a transaction, and isolation means that my transaction and your transaction don't conflict with each other. So one way to deal with isolation, I didn't put on the slide, is concurrency controls, like pessimistic concurrency and optimistic concurrency. Git uses optimistic concurrency, and most databases use pessimistic concurrency. So you acquire a lock on something. So it's not a merge conflict. Instead, long ago in the 2000s, I used another source control system called Visual Source Safe. I don't know if any of you guys remember that one. And you didn't get merge conflicts ever because you couldn't work on the code unless someone else wasn't working on it. You had to check out the files. And when I have the files checked out, you can't edit them. That's called pessimistic locking. So you can achieve isolation both ways. Right? You can try to do it through optimistic and having an error and having to resolve the errors, or you can do it pessimistic and acquire locks. With the kind of Mule transactions we're going to look at today, we're going to be assuming pessimistic locking. So things are locked and then you don't get errors. You just but when you acquire locks, everybody gets slower, right? Because you can't start working until I'm done. Right? So it makes all of our transactions slower. The other requirement, durability, is not something that Mule is needing to be responsible for, but it's important that if I take an action in my system, that the system doesn't forget about it, right? So if I send a transaction, and I don't just mean have final state, right? You can, if I do an update statement to a table in a database, it puts it in a transaction log, right? It doesn't just change the values in the table only. It also puts in the log that I did that. Like there was an action on Friday night at 6:24 p.m. where we inserted this row into the database. And then there might have been another action at 6:26 where somebody deleted my row. But my update is still in the transaction log even after the row's been deleted. So it remembers all the steps, just like in Git history, right? If I go add some flows to the application and then you come along behind me and delete all of them, they're not there, but there's a log that they were there and all of the actual little values and code that was in there. So all the details of the transaction are remembered, not something Mule has to do. The databases and the JMS brokers that we work with are responsible for durability, and so are the DBAs, right, Bara? So they can ruin it. So there is a matter of degree. Like you could have a little bit of durability or a lot of durability. You could just have a transaction log, or you could have it striped across 10 hard drives, or you could have it replicated to 3 different regions, or you could put it on blockchain and it'll be copied to thousands of people's computers. There's a lot of durability choices. None of it is Mule's concern. Mule isn't a data store, right? So Mule just has to trust the systems that it's working with to accomplish durability. So let's talk about Mule. Mule proper formal transactions are not supported in many of connectors in Mule. So it matters what the connector support is. And notably, API-led and HTTP APIs do not have any support for transactions, for the kind of ACID transactions I've been concerned with. Instead, you have to use the other connectors. So some of the connectors that support transactions, it's been a growing list since I started working with with Mule. It used to just be database, JMS, and VM. Now AMQP supports it, Kafka supports it, Redshift supports it. So you can look in the connector documentation and see whether or not it supports transactions. That's a connector feature that you have to investigate. CTG is pretty cool because that's kicks. So that lets you do real transactions with very old IBM computers, very old IBM computers. So it's not just new shiny things that support transactions. No, it's the other way around. Okay, so that's the first thing. It matters that you select connectors that are that support transactional actions. So what's a transactional action? You define it in order to demarcate your transaction. So you have to choose in your Mule code which element is going to be the beginning of the transaction. The first part of demarcation is where does the transaction start? So it looks like this. You're going to choose in Anypoint Studio or in your XML to have a begin transaction somewhere. And you really only have 2 choices. You either begin the transaction on a triscope, and then whatever else is in the triscope is contained in your transaction, or the other option is you can define a transaction on your event source, and then the rest of the whole flow is in scope for the transaction. And the only some event sources have transactional support. So here's some examples. And then so that's the beginning of the transaction. Then when the end of the transaction can end one of 2 ways. You can either roll back, and that happens in Mule if an error propagates, right? Or you can commit if an error doesn't propagate, and you can either not have one in the first place, or if you do have an error, you can use an on-error continue, and then it won't propagate the error back to the transaction, and you can still commit. So the way you control the transaction result is through error propagation in a Mule application. All right, now we're doing integration, so we need to at least talk about the possibility of distributed transactions. So a lot of times you don't need to use one. A lot of time we call them global transactions in a Mule application, but many times you can get away with a local transaction, and that just means you're working with one connector. And there are some connectors that only support local transactions and they do not support XA. So that's a special kind of transaction. XA is a standard defined by the Open Group decades ago, and many different technologies support the XA standard. So what it is it's a standard for 2-phase commit protocol. And that means there's a role, there's a program in the mix called the transaction manager. So if we're going to have a bunch of different programs collaborate to accomplish atomic behavior that we're all or nothing, right? They have to communicate with each other somehow. And the way that we coordinate that, the way we make the whole group of programs commit or roll back as one, is you have one of the programs be in charge. That's the transaction manager. It's the boss. And Mule has to be the boss. When we do Mule transactions, Mule only supports it being the boss, and all the other programs have to be resource managers. So that includes ActiveMQ, and that includes the Kick server, that includes your SQL server, whatever the systems are that have the transaction, they all have to follow directions, and Mule has to give the directions. So Mule is a transaction manager, they're all resource managers. And not only do they have to be involved in the transaction, they have to have explicitly, they have to have XA support in the software, and the the administrator has to enable that feature in the system. So that means the connector we use has to be XA enabled, and the other system has to have XA support, and the system administrator has to turn it on, and that makes XA work. So it really is a lot of things to make XA work. You have to make sure every piece of the puzzle is included, or you don't get an XA transaction. So XA is how you accomplish a transaction that involves more than one system. Okay. So I decided to take this to the next level. We're going to go a little further before we get into Mule. We're going to talk about using transactions with message queues. So I'm going to assume you have some familiarity with message queues. This is a key component of the reliability pattern in Mule, using message queues as a boundary for transactional steps that fit together into the Saga pattern. So the reliability pattern in Mule, you start out with a reliable acquisition, where you put something in a queue. So when you publish something to a queue with a transaction, that means it's not available to consumers yet. So you begin a transaction on the broker and you publish something into the queue. The broker confirms that the message is received successfully. So that data is on the message broker, but it doesn't allow any other consumers to have it yet because your transaction is incomplete. So it allows you to send something to the broker, but not have it final yet, right? So you haven't acknowledged the send. And then if you commit the transaction, it goes in the queue and consumers can have it. If it's rolled back, the broker forgets about it and nobody ever hears about it. So that allows you to have a step that you can roll back, a step where I publish something, but I make sure something else works before the publish is final. Very helpful part of a reliable integration. So you publish things transactionally, that's one piece of the puzzle. The other piece is receiving transactionally from the broker. So if Mule is receiving, before Mule goes and gets a message, it begins a transaction. And when Mule retrieves the message, the broker sends the data and holds on to the message. It doesn't get rid of it yet. It locks it so other consumers can't have it. So your process, the Mule process, has a hold of it and nobody else is going to get it. But until Mule's done with it, we don't commit the transaction. So we go do what we need to do. And if anything fails, we roll back the transaction. So if everything's fine, we commit the transaction, that acknowledges it to the broker. The broker goes ahead and deletes it and we're on our way, right? But if anything goes wrong, we roll back our transaction. Now what happens? The broker still has a copy, right? It never deleted it. So all we do is we reject the message. That's what happens under the hood. And the broker just keeps it and makes it available for someone else to get. So the data is not lost. So if you can combine these together, a publish and a receive, you end up being able to make reliable step-by-step integrations that do several, that if any step fails, the data is still where it started, right? So we need transactional publish and transactional receive. So what we've got today is a code example where we're going to imagine what happens when we have a transaction. So this is pseudocode. I haven't, this isn't going to run, but we're going to put transactions in where we need them. This code doesn't have any transactions right now. So we're looking at a flow that's involved in some kind of retail scenario, right? And we're imagining that it gets kicked off with an HTTP request that posts, hey, we're going to process a batch, okay? So we're going to imagine that there's a select statement to go get a batch for the tenant ID that's in the payload. Go process a batch for tenant number 355 or something. It's going to go select some records. So we're going to imagine, and I'm going to take advantage of my Zoom tools here. We're going to imagine that the select statement's going to give us maybe 1,000 orders this time, you know? So say we get 1,000 orders. This flow is going to loop 1, 2, 3, 4, 5, go through the orders and look up a warehouse ID for that order SKU. So maybe some orders need to ship out of our LA warehouse, and some orders need to ship out of our Toronto warehouse, and some orders need to ship out of our Mexico warehouse. So you don't know till you get the order which warehouse it has to ship from. So when you get the orders, you go look that up and you put them in their queues so that all the Mexico orders ship, all the Toronto orders ship, all the LA ship separately out of the right warehouse, right? So you're putting them in different queues. So we loop through, we put them on all their queues, and then when we're done, we go update the orders that they've been shipped. That's what we hope is going to happen, right? Now, everything doesn't always go according to plan, right? So let me use red. So maybe we're running this process and we get an error. So let's say like order number 5 gives us 503 service unavailable. Uh-oh. Okay, so what happens now, the way we have it coded without any transactions, is I want you to think about how many orders ended up going to warehouse queues. Put that in the chat. How many orders are been going to be shipped out of warehouses? Now we want 1,000, right? We're treating the 1,000 as a batch, right? So all 1,000 are supposed to be shipped, but that's not going to happen, right? I wish it was none. It's worse than none. It's Sajid's got it, right? So we're going to send 4, then we're going to encounter an error, right? And then we stop. So 4 orders get shipped, 996 don't get shipped, right? And how many get marked as shipped? How many are going to have the update statement succeed? That's a 0, right? So 4 people are going to get their item, and then it's still going to say it's ready for shipping. So some people are getting some free stuff. That's good for them. That's not good for us, right? We're about to double ship some stuff. So this transaction has an atomicity problem. This is atomic, so violates atomic behavior, right? So this is a violation of atomicity. We only ship 4 out of 1,000, and we never want the batch to be incomplete or partially done, right? That's not good. So we need to fix that, right? We're going to fix that. So one way we can fix that is, of course, we're going to demarcate a transaction. So let's put a try in here, and we're going to put the whole iteration, the whole for each, inside the try scope, right? And we're going to mark the try scope as begin transaction. So now the transaction is going to begin. We better check our JMS connector. Now, luckily, the default in any point is that it's going to join if possible. Even so, I like to mark it always joined anyway, because I want these all to be in the transaction. Okay. So now, how this is going to work is when the query comes, we're going to begin a try scope. So a transaction starts here in Mule. We're going to look up a warehouse. We're going to begin a transaction on the JMS broker and publish. So when we publish it, it's not going to the warehouse yet. It's just published inside a transaction. So we do 1, we do 2, we do 3, we do 4, and then let me do this. Let me erase some stuff. And now order number 5 fails. 503 service unavailable. And what happens when you fail inside a transaction? You get a Mule error. The transaction is rolled back. Right, so we send a rollback to the broker, and all 4 of those publishes get forgotten about. Oh, never mind, transaction rollback. We're not publishing those 4. So now 0 of them are published, and all of them still show ready state. So at least our atomic behavior is intact, right? We've got an atomic transaction. That's good for 1,000 units, right? Now we're going to do consistency, right? So we're happy with the behavior. We commit, we push, we deploy to the QA environment, and we run an end-to-end test. And again, we have 1,000 in our batch in our QA environment. And we run this, and we're very happy with it. However, when this process runs in end-to-end testing, we get a different error. This time we get access denied or update on the update statement. Well, shoot. Now, how many orders are shipped? In QA, luckily, but is that Rohit? I should have put a mark there. Yeah, Rohit says, or he's, no, wait, that was 8:36. That was 3 minutes ago. Any ideas? We rolled them all back, right? So no orders got shipped, right? And how many? No, wait, we didn't roll any back. We committed, right? We finished the whole loop. I got that wrong. You got to put it in the chat. That's why I asked. So we do 1,000 of them. We publish 1,000 into queues, maybe some to Mexico, some to Toronto, some to LA. they're all shipped, and we have no errors. So we commit the transaction at the end of the try block, and then we encounter an error trying to mark them as shipped in the database. So we've shipped 1,000 orders, but how many say status equals shipped? None of them do. So now we've shipped all this stuff to everybody, and it still says ready to ship. So tomorrow we're probably going to ship it again. So that's going to be double shipping. So we have inconsistent state in the system, right? So we want to prevent that. What we do is we put the database update inside our transaction. So now it's included in a transaction. Of course, now we have to change something because now we have a transaction that involves a distributed system. We're going to have to use a global transaction. So I'm going to click on my try block. I'm going to change the local to an XA. XA transaction is required if I want to use two different connectors in the transaction. So I make an XA transaction, and I have to go check more. I have to make sure that my JMS configuration supports XA. So there's a little checkbox here on the factory configuration for ActiveMQ, for example. You got to, whichever broker you're using, you have to make sure XA is enabled for that. And same thing with the database configuration. You're going to have to make sure that you have XA support turned on. So, and then you better call the DBA and make sure they have XA turned on, and make sure that you go check the JMS broker configuration. All of it has to have XA enabled and configured in the environment. So once you've turned on your XA in the whole environment, now we have one more step. We have to add, give Whitney extra credit. She called this before the meeting. We have to add a Metronics transaction manager so that Mule can be the transaction manager. And it doesn't require any configuration, but you do have to include that global element if you want an XA transaction to function. So we put the Metronics transaction manager in, probably in our global XML. So my code's a little disorganized, but it would work. And now, even if the update statement fails, we're going to roll back all those JMS publishes. So we fixed another potential reliability problem with our application. That would have been a consistency error. So that's consistency. All right, so how do we observe isolation? Okay, let's do isolation. Isolation is when different transactions can interfere with each other. So let's imagine this process is running, and let's see. Well, I'm gonna pick on you again, Rohit. Rohit decides to run a different process in the QA environment, and his process cancels orders. So what if while we are running, what if another process cancels 10 orders, right? Set status equal canceled. Okay, so while this process is going on in the middle of our loop, 10 orders get canceled. Think about what the result's going to be. I'll give you a second to think about it. So we select 1,000. Those are in the payload. We have all 1,000 in the payload. We start our transaction and we start looping and putting them in queues. 10 orders get canceled. We still have 1,000 in RAM, right? So 1,000 here in the Mule event. And then when we're done, we update 1,000 and set their status equal shipped. So our process has no problem. Our process is fine. But Rohit's project is QAing and he cancels 10 orders and they still get shipped, right? That's not good for him. So we pass QA and he's mad, right? Because all of his canceled orders got shipped. So we need a way to use pessimistic locking, right? We need a way to lock those orders while our process is going on. Yeah, it would have been totally outside MuleSoft, Vikas. So I got a question. Vikas said, are they getting canceled using this flow or something completely outside of MuleSoft? Yes, directly in the database, something else cancels the 10 orders. And then we come along and mark them shipped after we're done, right? Because maybe this process takes 3 hours. I don't know how long it takes to look up a warehouse. Maybe it's a very slow system API. I don't know, right? But whatever it might, however long we're running, those orders are at risk, right? So until our transaction is completed. So what we want to do is take advantage of the database isolation level. So we're going to put the select statement inside the try. Now, when the transaction is begun, and then we select our records, and I'm going to show there's a setting, and you want to read the documentation for the setting. So in MySQL, in Microsoft SQL, you can set the transaction isolation here. The lower serializable is like the most extreme one, and then they back off as you choose the different ones. But let's say we picked like a very high level of isolation. The database is going to make sure that nobody touches our rows while we're running now. And that means the other transaction has to wait until our transaction is done before it's allowed to update those rows. So now we have a transaction that is not only atomic because we have all of the publishes in one transaction. It's not only consistent because we included the update in our transaction, it's isolated because we included the select, right? And it's a big problem for Rohit's process because now his process has to wait a big long time before ours is done, and you will get lots of DBAs mad at you if you do this a lot. It's going to wait. Rohit said, will the cancel flow fail or wait? It's going to wait unless it has a timeout, then it'll fail if it takes too long, right? So we want to design our process to be less disruptive to all the other processes and also be safe. So I have another example, of course, right? This is going to be very safe for us and also make the database really slow, right? So what if we break the process into 2 stages? No, well, I'll hold before I do that. I mean, take the next question. It says, will this prevent our process from running when an external process is updating the data in the database? Yeah, our select statement has to acquire a read lock. So if someone else has a read lock, we can't. We block. Our process will block right here at the beginning before it's allowed to have the rows. So sometimes you're the one affected instead of the one making everybody else slow. And really, what we're going to have to be responsible for when we start doing transactions is we're going to have to be responsible for the duration of our locks. How long are we going to hold things and not let other processes have them, right? So this process is designed in kind of irresponsibly because we have a for each that's going to do an HTTP request 1,000 times. So that's going to take a long time, right? So we need to reduce the latency in order to make our locks get released faster on the database and other processes can continue, right? And that's why we might want to break our process into 2 stages. So this is called stage CETA for transactions, right? So imagine that a first stage now still uses an XA transaction, but we select our rows, we put a single batch of all of the rows in a queue, and then we update them to pending instead of shipped. So now Rohit's process can decide what he wants to do about pending rows. If an order is canceled and it says pending, he can do something different than if it says ready. You know, he can treat pending rows, maybe he notifies somebody, I don't know. He can do something about the pending rows. In our last process, he doesn't know we're working on them, right? Here, we're going to create a stage where we update the data to say these rows are not available anymore, right? And we very quickly complete our transaction. This whole thing is going to execute in no time, right? It's going to be like very fast because we select 1,000 rows, put them in a queue, update them all to pending, commit, done, right? And now we have to do something to process the rows. But as soon as you start using a queue that way, you need to do the reliability pattern. You need to use a transactional receive on the other end. So here, we're not going to use a try scope in our second flow because the try scope is too late. We want the transaction to include the receive. So in the event source, you have to define your transaction. So I have a pending queue and you define the transaction to begin right here at the event source, and the whole send to shipping flow is the transaction. And it's the same thing as the last flow. So you see how this flow at the bottom, the send to shipping flow, it's kind of the same thing that was in the try. right? I'm going to do for each and lookup, publish, and then bulk update. So here we're going to do a for each with a lookup and a publish and a bulk update. But if anything here fails, the whole transaction rolls back and the batch is still sitting there in the pending queue. So we don't throw the message away out of the pending queue until we have completed everything. So I'm checking the time. I'm at about 40 minutes, Rohit. I could keep going, but I'm going to take some questions. I see some here. Will the type be always joined for the 3 connectors after the VM receive? Not for the HTTP, because you can't join with HTTP, but it works with join if possible, which is the default. I think that's what I left, and I prefer always join, because then if somebody comes behind me and clears out the transaction on the new message, then we'll get an error. So I rather have always join. I think it's cleaner. But both will work. Join if possible also works. So there's a transactional action on each one of the operations, and you can choose join if possible or always join. And if you choose not supported, then it I don't know if it'll error or if I think it'll just not participate, but it might error. Probably it will not participate, and now I want to do an experiment, but we will do that in a different talk. So I'm going to put always join. Always join is how I do it. So good question there. I'm going to do one more step then, Rohit. Rohit says I'm good to continue in the chat. So we're going to do a bonus. It's like an encore at the end of a concert. Wait, I got another question first. In case of failure in the second flow, the database status will remain pending, and we need to handle the failure externally. That's exactly the point. Yeah, we wanted to make it so that once we've started working on these rows, you can identify them. Right, you can identify the orders that are not ready to ship anymore. They're already pending shipping, but they haven't shipped. Right, very exactly true. We need to do something about these. Now we can make an error state. Right, I can make failed shipping or something as an error state. In order to do that, we still want to do it transactionally though. So that gives me an excuse to go to the next step. So let's say we have one where it's not failing in the request. It's not a temporary failure. Let's say it's something more serious. So let me say, maybe, for example, maybe before I do the for each, I need to do a transformation, and I have a bug in my data weave or something. So this is like fail, right? That's actually isn't there a fail? I think there's a fail. Maybe it's a DW runtime fail. Somebody's gonna have to help me out there. Yeah, there it is. So let's just say I have a data weave expression that has a bug. Yeah, better. Thanks. I know we went over time. See you next time. You're gonna miss the trivia. I'll just do this last one, Rohit. So now we've got a permanent failure, not a temporary failure. Or even worse, let's say it's a good transformation, but let's say it's something where just one order fails the transformation. Right? What about something like that? So every time we retry, it's going to fail permanently, right? We need to do something about permanent errors. So let me do this. So we have a permanent, we have one order, always errors in transformation. How about that? So however many times it retries, it's going to fail over and over and over again, right? We have an infinite loop, right? So we need to do something about that. So what you can do is you can use the redelivery policy on the event source, and you can tell it, I only want, I don't know, two redeliveries, right? And you give it a way to recognize the redelivery. Here it's going to use a secure hash, so it'll figure out that it saw the same message 3 times. And now we're going to get a Mule error, so we can use an error handler to continue. So we don't want to roll back the 3rd time we see it. We want to continue. So I'm going to put the error handler in here with a JMS retry exhausted, right? And I don't need to log the exception because we know what happened. And what we're going to do is go put it in a dead letter queue. So we can publish it into a different queue that lets us handle the ones that have permanently failed differently than the rest. So this will be my orders to manually fix or something. We make a queue that makes sense for us to publish the broken ones to, right? And that's called a dead letter queue pattern. And you commit the transaction. That way it doesn't stay in the pending queue anymore. It goes off there. So that's one way to, it's not the only way, but that's one way to handle permanent failures. All right, Bear, see you next time. All right, so let's do, let's call that the end of it, Rohit, and we can, I have some, do you guys do trivia at this meetup?
Not exactly, but yeah.
We can do it for fun.
Yeah, let's have it.
All right, let's do it for fun. All right, so what I want you to do, see you next time. Trivia 1. So I put trivia 1 there. So in the chat, I want you to put the answer. What do we call an unsuccessful transaction result? And you got the 4 options on the screen. Vikas got it first. All right, they're not all going to be that easy. Okay, here go. I got 3 questions. Here's number 2. Which of these connectors is compatible with transactions? Yeah, good. Oh, that was really close between Vikas and Sajid. Oh, it was like boom. It was like a second. So Vikas got it. You liked tragedy, huh? Yeah. All right. I think this one's the hardest because it's got the most words. You're gonna have to read it. All of these are required to use an XA transaction, except which one? Which of these is not necessary? Yeah, letter D. Of course, you don't have to deploy to CloudHub 2.0. So, okay, yeah, that's all I got. Rohit, back to you. You want your car keys back?
Yeah, I'll take my car keys back. But I have a follow-up question, Ryan. How the message queue is different on the on-prem RTF compared to CloudHub?
VM queues?
Yes, correct. Message queue, yes.
Yeah, if they're VM queues, so RTF and CloudHub 2 don't support persistent queues. So, and CloudHub 1 does.
Okay.
So that means you get clustering. You can have your replicas share a queue, but they won't be any, like if your whole app is deleted, the messages are gone.
Messages are gone. But as long as the app is there, the reliability will be there?
While the app is there, yeah. Yeah, and that's one reason, because you don't have persistent queues, like I don't want to use it for long term. Like I'll use it for a day or 2, but I don't want a message to have to live a month because there's way too many ways you could lose it. Okay.
So yeah. we had the similar reliability situation, and I think instead of using the VMs, we are using AWS SQS on the on-prem cluster, basically.
Yeah, yeah. I think MuleSoft officially is recommending AnyPointMQ for that, but certainly SQS is great. Or I think I'm using Amazon Service Bus.
Okay.
I'm sorry, Azure Service Bus.
Awesome.
Yeah. Awesome. So we got a picture to do, right? We're gonna do.
Yeah, we are gonna do a picture, and if everyone can turn on their camera, if possible.
I'd love to be in a group photo.
Group photo.
Do your hair. Do your hair. Yeah.
Anybody else would like to turn on the camera? Okay. Never mind. I'll take a picture. Thank you. All set. Thank you, Ryan. Okay, perfect. I'll take once more. Thank you, Ryan. Thank you.
Yeah, you're welcome.
This was an amazing. I think technically this is really good, and I think this is going to help many people for the reliable transaction. Thank you, everyone. Thank you for joining, and have a good weekend.
Thank you. Bye.